continuation of where we left off yesterday, we talked about angle-angle similarity. We did an exploration with it, and we had some GeoGebra triangles, some triangles in GeoGebra. And we found that when one angle was 106 in one triangle and a 106-degree angle in the other, and then we had a second pair of angles that were congruent, 31 and 31, that those sides were always in proportion with one another. So that was similarity. Today we're going to formally state that theorem. The theorem says that, and this is on the top left corner of your notes sheet / worksheet, it says that if two angles in one triangle are congruent to two angles of another triangle, then those two triangles are similar. All it takes is two. Okay, two pairs across both triangles is enough. So on your notes sheet, write down that if angle A is congruent to angle D and angle B is congruent to angle E, like they have marked on your figure, then those triangles are similar. We only have to get two pairs. When we're writing those similar statements, we have to be very careful about the order in which we write them. So if angle A was equal to angle D and angle B was congruent to angle E, then those two triangles will be similar. And you can write them in many different ways, but we're saying triangle ABC. That means that we have to go to the same angles on the other triangle, similar to triangle DEF. So the angles have to match up. A matches D, so they're the first ones written. B matches E, the second one's written. C and F we didn't know anything about, and that's okay. They're going to be congruent as well because 180 minus those other two will be the same measure in both triangles. So far, so good? Any questions on this one? Okay, so the next slide then is an example, like the kinds of problems that you're going to see numbers 1 and 2 below it. So we want you to figure out if these two triangles are similar, and if so, write a congruence statement. And Jake's already shaking his head no, and he's getting ready to say because. Okay, so I see two angles that are congruent. I see a 35 and a 30, sorry, I'm on the wrong one, a 21 and a 21. Okay, so we have to get another pair of angles that are congruent. And Braxton's shaking his head no as well. Good. Why are we saying no? Because S is equal to what, Braxton? And 98 doesn't cut it. 98 is not 99. Okay? So we'll say no because we have only one pair of angles are congruent. Okay? Got to have at least two pair. Okay? Had they been congruent, we would have been able to write a similarity statement. And we have to be careful to make sure the angles match up when we write them. Okay? Watch the order. So numbers 1 and 2 are very similar to what we just did. Questions you have about this one? Okay? Let's move on to the next slide. The next group of problems they'll ask us to do is to show that a triangle is similar to another triangle. In this case, they want triangle QPR to be similar to triangle QTP. What makes this problem kind of difficult? Yeah, we're embedded into each other. It's cut, right? So if it helps you, draw this smaller triangle, rotate it out. Okay? Draw that little triangle, rotate it out. That way they're in the same orientation, because I'm one of those people that has to see them in the same way, and then it makes sense to me. Okay, so draw a little triangle PTQ off to the side. Okay. Now we have some easy angles that have been already shown to us, right? Which two angles are marked? This large angle at P, so angle QPR, is going to be congruent to what in that small triangle? PTQ. Because they're 90 degrees, right? Okay. So we know we've got one pair of angles congruent. Now we just have to find one more pair of angles to be congruent. Looks like angle R and angle P in that little triangle will be congruent eventually. Can we get that though? Q and Q are the same angle. I like that. Okay. Notice that that angle is in both triangles. So angle Q is congruent to angle Q. And there's only one angle up there called Q. So we can use our one angle name, our one letter name for it. It's similar to a proof, but I'm not asking you to say this because all right angles are congruent and this because of reflexive, right? You're just giving me these two, and that's enough. You've shown me two pairs of angles are congruent. No formal proof, just reasons. Okay? Or just statements, not the reasons. Everybody good with this one? Questions you have on this one? Okay. So, last example. It is a sunny day out, but I didn't have enough tape measures to do this. I would have loved to take you outside and actually figure out a... Oh, I'm sorry. It's because it's because it's the same angle. It's in both triangles. Yep. You can say that the measure of angle Q will be equal to the measure of angle Q, or you can say that angle Q is congruent to angle Q. I would probably put an angle mark and a congruent symbol. Perfect. Okay. Okay, sorry about that. So I would love to have, I didn't have enough tape measures to do this, to take a group of us. in terms of bodies, how many Brandons did, how many Brandons was the length of the channel? Okay, maybe we'll try to do something like that. Okay, so the idea though is that you can actually use shadows and a known height to calculate an unknown height. Okay, so I'd like you to draw a flagpole in that box that you've got for your example. So draw a flagpole. You can put a flagpole and you can put a flag at the top if you want to. Decide how much of a Picasso you want to be. Okay. Everybody got a flagpole? Now draw the shadow. Now, provided that they installed the flagpole correctly, what kind of angle should we have here? A right angle. Okay, so there's my flagpole. Here's my shadow. Now, draw a person, a boy. I would go a little bit separated so that you have some, so you don't have things overlapping, because it's easier if triangles aren't overlapping. So draw a boy. Can be a stick figure. Okay, and then draw his shadow. It's got a shadow. Okay, and again, as long as he's not on a hill or something, so that he should be straight up and down, right? So we've got another right angle here. Everybody got a boy and a shadow? Now we're going to draw the sun, where the sun would be going. So provided we do this at the same time of the day, the sun's up here somewhere. Won't be a shadow, right? Okay? But the sun is what's making that shadow. So this angle here, you can call it theta, you can call it x, you can call it y, you can call it whatever you want to. But that angle will be the same as the angle made by the sun and the boy. So everybody got it? Okay. So we've got our picture. That's part of the battle. The other part's getting the numbers in the right place. So the shadow is 45 feet. Where do I put 45 at in my drawing? At the base of the flagpole's triangle, right? So this is 45 feet. That's the shadow. Okay. A boy is 5 feet 8 inches tall. He's short, okay? Or you, taller than me, okay? 5 feet 8 inches tall, okay? So we have to make that, let's make that into a decimal because our calculators understand decimals, okay? So 5 feet 8 inches is how much? Not 5.8. What is 8 divided by 12? He's 5 feet 8 inches tall. Okay, so this is 5.6 repeating. That's his height. 5 2/3. Okay, everybody got 5 2/3 or 5.6 repeating there? Yep, we just took the 8 divided by 12 to see what fractional part of a foot his inches are. Okay. Now we have one more number here. We want to know, first of all, we have a 51-inch long shadow for this boy. 51 inches. Everything else is in feet, right? So let's change the 51 inches to feet. 4 feet 3 inches is 48 feet in 48 inches and 4 feet plus 3 more. 4 feet 3 inches. 3 out of 12 is 1/4, right? So 4.25 feet for his shadow. Bless you. Okay. Now all that's left to do is find the height of the flagpole. Here's my flagpole. Are we going to write our big triangle to our small triangle or the opposite way? Big to small. So if we're saying big over small, and we're trying to find x, let's start with x. X corresponds to what in our little triangle? 5.6 repeating. Okay. We're going to set that equal to 45 over 4.25. And we know how to solve these, right? Caleb, how do I solve something like this? Cross multiply. So I'll do the easy part. 4.25 x equals, and you all have a calculator in front of you. What'd you get? 59.29. 2 decimal places is probably accurate enough for what we're doing. And then when we divide, that was actually after you divided, isn't it? Okay, so her final answer was 59.29 feet. When you took 5.6 repeating times 45, what did someone get? What'd you get? 252. And then our final answer is x is 59.25 feet, 29 feet. Last step on these problems is always to ask ourselves, is this a feasible answer? Does this even make sense? Would a flagpole be about 60 feet? Absolutely. Okay, so we're good. Do you see how surveyors potentially use this type of technology or the similar triangles to do things? Okay, surveyors do when they're surveying a road. What's that? Oh yeah, exactly. An Empire State Building would be difficult because it would be hard to see where that shadow actually falls or where it ends. And even in a a redwood forest, it would be difficult because there's so many other trees around it. But they do use these similar triangles when they're trying to find the width of a river or how wide a lake is, especially when they can have a line of sight with trees out. Okay, so assignment is the rest of this worksheet. Now, if you are somebody who worked ahead and started the book assignment, you've already done that. Okay, you can just staple your book assignment to it. The worksheet, I just took those problems from the book, put them on your sheet instead, so you won't have to take a book home. Okay, so front side is this stuff, back side is a little bit from the last section to make sure we have some more practice on that so we understand it. Okay, so what questions do you all have? Or are we good?